Hey y'all, welcome back to another video here for Geology 105. I'm feeling bad that I didn't wear black to make this series of videos because we are talking about metal. Not heavy metal, but metals from the earth, of course, which I guess could be heavy. So as we're kind of moving away from all of the energy stuff we've been talking about in class, the next kind of major group of resources that we get from the earth are metals, and metals can be put together in lots of different categories. As we've tried to do with this class, I really just kind of want to give you guys the general idea, right? With the acknowledgement that obviously, this goes much deeper. You could get a degree in mining engineering and learn a lot about this stuff. But fundamentally, we have to just do some definitions and kind of think about what these terms mean. So a metal. Well, the Earth is about a quarter metal. The core of the Earth, which is the most dense portion of the Earth, is mostly iron with some nickel in it. So we would call it a nickel or an iron-nickel alloy. Right? An alloy means two different types of metals mixed together. And you can see here, this is an exploded diagram of the inside of the Earth. Both of those yellow portions that you see, we have the inner core, which is solid, and the outer core. They are different in states of matter. One's a fluid, one's a solid, but compositionally they're identical, right? They're all this iron-nickel alloy. We know that for a couple of reasons. So first of all, when an earthquake occurs, this is getting into the realm of geophysics, the seismic waves pass through the Earth, and they pass through different materials at different rates. And so we see that they reflect the sorts of velocities we would expect to see with metals as they pass through the Earth's core. Also, occasionally the cores of planets rip down through the atmosphere and fall to Earth, right? If a planet were to collide with something large in kind of outer space and fracture into a million little pieces, a lot of those pieces are going to be from that planet's core, and they come ripping down into our planet, and we call those iron meteorites. There's actually a lot of different types of meteorites. In the neighborhood of 15 to 20% of the meteorites that fall to Earth are what we call iron meteorites. And you can see here, we'll touch back on these a little bit when we start talking about metals specifically. But you can see here, this is a fairly large meteorite. It kind of has that nice metallic sheen. As it comes through the atmosphere, it burns, and right, it's kind of burning and vaporizing the metals that are on the outside, so there's this very specific kind of scorched crust. In this next slide, you can see one of these meteorites that's been cut open and actually polished. And the metals in the Earth's core, or the metals in the core of a planet, take a very long time to grow, and so they don't look like a regular metal. They have these very long crystals that have grown. So similar to a rock, as it transitions from a liquid to a solid, it takes a very long time to happen in a planet's core. So the metal crystals are very large. And you'd find if you looked at a piece of steel or iron today, and you looked really closely with a microscope, you'd see very similar patterns. Just in this case, they've had time to grow large. Okay, so the next thing we have to think about is the definition of a metal. And the definition really comes down to the atoms and how those atoms behave. So there is something that we call a metallic bond, which fundamentally is the definition of a metal. Things that have metallic bonds are metals. So this is the concept, right? So in a metallic bond, we have a network of atoms, actually, as you can see here in this image. So the nuclei of those atoms are arranged in a very particular way, but the electrons which travel around the nuclei are actually not bound to one nuclei in particular. They're actually free to travel out through the whole network, which means the electrons flow like crazy. So again, this diagram, you can just see the yellow dots that are indicating electrons are kind of all over the place. In this next one, you can see it's actually more accurately showing the electrons as these kind of clouds, right, as they're moving around. Which, as you can imagine, if you have a compound in which electrons are free to move around, you can probably control how those electrons move And that is something we would call a conductor, right? So you can do it with a copper wire. That's why metals conduct electricity, right? Because they have metallic bonds. So if you're transmitting electricity from one area to another, you would use a metal. Often we use copper. It turns out it's not the best conductor. Some others are much better conductors, although they're soft or they're very expensive. So copper is tough enough, cheap enough, and transmits electrons with a reasonable enough efficiency that we use copper primarily. Ore is a term we're going to use quite a bit in this discussion. Ore is essentially a rock that contains a mineral from which we can extract a metal. I know that's kind of a few different steps there. Sometimes metals do occur just bonded with themselves over and over. We would call that a native element. It will happen with gold. It will happen with some other, copper as well. So most often, those metallic elements are actually tied up within the molecular structure of a mineral. So a really good example, just kind of off the top of my head, would be malachite, which is kind of a common ore for copper. So the formula for malachite, which is copper ore, is Cu, so 1 part copper and then carbon and 3 parts oxygen. We would actually call it copper carbonate if you're really into your chemistry. So if we want to get the copper, we need to figure out how to break this bond, take our copper over here and get rid of our carbonate ion over there. That's something that we'll explore a little bit later. But fundamentally, just know that ore is a rock that contains minerals, and within those minerals are metals. There's a couple of different ways that it can work out, but we'll explore those as we go through, so we don't need to do an exhaustive list here.